Our today's lesson plan is 5-number summary and box plots. By the end of this section, we will be able to calculate the 5-number summary of a data set, construct and interpret a box plot for a given data set, detect outliers using the IQR method. The 5-number summary consists of the following set of statistics, which together constitute a robust summarization of the data set. Minimum, the smallest value in the data set. First quartile, Q1 or the 25th percentile. Second quartile, the median or the 50th percentile. Third quartile or the Q3 or the 75th percentile. And the maximum, the largest value in the data set. Constructing a box plot by hand will require us to remember the following steps. First, we're going to determine the lower and the upper fences. To do so, we're going to find all the quartiles, find IQR, then call the lower fence as Q1 minus 1.5 times IQR and upper fence as Q3 times 1.5 times IQR. Draw a horizontal line that encompasses the entire range of the data, including the fences. Above the number line, draw vertical lines at Q1, the median, and the Q3. Connect the lines for Q1 and Q3 to each other so that it forms a box. Temporarily indicate the fences by brackets, lower bracket for lower fence and upper bracket for upper fence above the number line. Draw a horizontal line from Q1 to the smallest data value greater than the lower fence. This is the lower whisker. Draw a horizontal line from Q3 to the largest data value smaller than the upper fence. This is the upper whisker. Indicate any data values smaller than the lower fence or the larger than the larger fence, upper fence, using asterisk. These data values are outliers. Remove the temporary brackets. If the box is located closer to the lower whisker, then the data distribution is right skewed. And that is the right tail is longer. If the box is located closer to the left whisker or the left tail is longer, then we call it if the box is located closer to the right whisker or the upper whisker, then it is left skewed when the left tail is longer. In the IQR method, we can find outliers as well. A data value is an outlier if it is located 1.5 times IQR or more below the quartile 1, or if it is located 1.5 times the IQR or more above the quartile 3. So let's sum it up. Using the following data of commuting times in minutes for 12 community college students, answer the following questions. So it's a data set, and we're going to first write it in increasing order. So the lowest commuting time is 10, and I have 2 of them. So I would say 10, 10. Then I have 15, 1, 2, 3, 4, and 5 of them. So 1, 2, 3, 4, 5. The next commuting time is 20. I see 2 of them. Then I have 25 twice, and then I have 50 once. So these are my 12 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the quartiles. So first question first is the quartile. Just like the last example in our last section, sample size is even. It's a little more work in this situation. Sample size is even and it is 12. So we're going to find the median, and I always want you to remember the median is the 50th percentile. So you can actually find the 50th percentile this way. I'm just going to use the median process. So the 50th percentile or the median will be found because the sample size is even. We're looking for 12 plus 1 over 2. That's 13 over 2, which is 7.5. That means we're looking for the 7th data on the left hand side and the 8th data on the right hand side over 2. Well, the 7th data in this distribution is 1, 2, 3, 4, 5, 6, 7, and the 8th data is 20. So it's 15 plus 20 over 2, and that is 35 over 2, which is 17.5. And that's the median value. So the median value is 17.5 for this distribution. So let me count one more time to make sure that I have not done any mistake. So 1, 2, 3, 4, 5, 6, 7 is 15, 8 is 20. So that makes sense. Oh, it should be 6.5. 13 over 2, it should be 6.5. So that changes the calculation a little bit. I'm so sorry. So let's go ahead and do it one more time. 13 over 2, I said 7.5. It should be 6.5. So you are looking for the 6th data on the left and the 7th data on the right. 6th data on the left will be 15 and 7th is 15 as well. So this is 30 over 2 and that's 15. And this is quartile 2. So the median is my quartile 2. Once I have done this segregation of data, I will say 1, 2, 3, 4, 5, 6. So this is the median 15. So that is the left-hand set and this is the right-hand set. But each set has 6 elements. So sample size is 6. So you're finding the median of the lower half now. But sample size is 6. So I'm looking for 6 plus 1 over 2, which is 7 over 2, and that's 3.5. So find the third data plus the fourth data over 2, and that will be quartile 3 or the 25th percentile. And I want it. So the third data of the distribution is 15 and the fourth data of the distribution is 15 as well. So it's 15 plus 15 over 2. Similarly, it's 30 over 2 and hence 15. So quartile 3 is 15 as well. And finally, we're going to do it for the upper half of the data, which is this one. I still have 6 data there. So for the upper half, again, since I have the 6 as the sample size, I'm looking for the third data in the upper half and the fourth data in the upper half and divide by 2. Add them and divide by 2. Third data in the upper half is going to be 20, fourth is 25. So you add 20 and 25, divide by 2, so that's 45 over 2, and that is 22.5. And remember, this is the quartile 3 or the 75th percentile. So fairly, I'm going to write down the information that I have found out. Quartile 1 is 15, quartile 2 is 15, quartile 3 is 22.5. So we'll carry on. Calculate the interquartile range. So IQR is quartile 3 minus quartile 1, which is 22.5 minus 15, and that's 7.5. So now it is telling me to find the 5-number summary. Remember, it's the minimum value. So minimum value is 10. Quartile 1 is 15. Quartile 2 is 15. So for your understanding, I'm going to write it how I'm doing it. Quartile 3 is 22.5. And it is followed by the maximum value. And that is 15, our distribution. When I write them all together, it is the 5-number summary. Use the IQR method to determine whether 10 minutes is an outlier. So first I need the lower fence. So lower fence and upper fence. These are the things I'm going to find out first. And they have nice inbuilt formulas. This is quartile 1 minus 1.5 times IQR. So we have values for each of them. This is 15 minus 1.5 times 7.5. Because IQR that we found out in the question is 7.5. So let's see what we get. We get 15 minus 1.5 times 7.5. So 15 times 5 is 75. 15 times 7 is 105 plus 7 is 112. So I get 11.25. So that is going to be 3.75. That's the lower fence. So this is where we're going to have this. The upper fence is going to be quartile 3 plus 1.5 times IQR. So this is 22.5 plus 1.5 times 7.5. So I don't have to do the calculation one more time. It's 22.5 plus 11.25. So I get the answer readily. And this is 33.75. And at that point, you get the upper fence. Now the question is 10 minutes is an outlier? It will be an outlier if 10 minutes is less than 3.75. Since 10 minutes, so I'm going to go ahead and say that for the checking, since 10 minutes is greater than the lower fence, it is not an outlier. Similarly, use the IQR method to determine whether 50 minutes is an outlier. So 50 minutes is actually, this time, it is crossing the upper fence, which is 33.75. And then it is an outlier. And finally, use all this information to construct a box plot for commuting time. Because I don't have space here, I will actually go to the last page and draw the box plot there. So the process is, you will start by taking a large enough horizontal line that encompasses the entire range of data, 10 to 50. So I'm going to label them this way: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and good enough. So now you are going to identify quartile 1 a little over. You will put a vertical line, and that's also quartile 2 for you. 22.5 is half the way between 20 and 25. So that will be the quartile 3. And then you connect these lines in a way so that it forms a box. Now I need the lower bracket and the upper bracket. So the lower bracket is going to be the lower fence, which is 3.75. So it should be here. And the upper fence is 33.75. So it should be somewhere here. That's the upper fence. Identify the lowest value, but bigger than the lower fence. Clearly that's 10. So it's here. Identify the highest value, but lower than the upper fence. The highest value is 50, but the highest value that is lower than the upper fence is 25. So if we go back to the commuting times, we will see that before 50, the highest value is 25. So the highest value that is lower than the upper fence is 25. So that's there. And you connect them by horizontal line, and these are the whiskers. And I have done drawing the box whisker plot, except now I have to locate the data 50 and call it as an asterisk, and this is the outlier. Once you are done drawing, you are supposed to take the brackets or the upper fence and the lower fence out of the picture, and this is the box whisker diagram. And see, the tail on the left is longer than the tail on the right. The whisker, this one is longer versus this one. So I say that this is a leg skewed distribution. Okay, so let's come back to our last problem and answer this question. Construct a box plot for commuting time, which we have done. Then we have given bunch of box plot, and depending on them, we're going to answer some question. Which pitch is typically thrown the fastest? So if you look at the fastest pitch, speed miles per second, is this one. That's the typically fastest pitch, is the 2-seam fastball. So that should be the answer to the first question. It's the 2-seam fastball. Which pitch is most erratic as far as the pitch speed goes? So which has the largest variation? Now, none of these box whisker plot are symmetric. So we are looking at the interquartile range. And I would say, again, if you look at the 2-seam fastball, it has outliers here. And it is kind of, the interquartile range is long, this bigger than any other of the distribution. So we'll say that the most erratic, the most sparse data is the two-seam fastball. Because the distributions are not symmetric, we are using the interquartile range to determine the measure of variability. And because the two-seam fastball has the largest box, the largest interquartile range, and it has outliers too, in my mind, this is the most erratic one. Okay. The next question is, which pitch is most consistent? So this time you are trying to talk about the pitch that has the smallest interquartile range. So see, the smallest interquartile range probably is of the changeup, but it has outlier. So I'm going to go ahead with the interquartile range, and I would say that my answer probably is going to be changeup. And someone might value with me and say that, well, because it has an outlier, I want to go with the four-seam fastball, because this one also has a small interquartile range. So four-seam fastball. Either of these answers are acceptable. In my mind, the changeup is the best answer because the interquartile range, the quartile 3 minus quartile 1, is the smallest in this type of the baseballs. So four-seam fastballs. So as I said, either of them will be accepted. Are there any outliers for Halliday's cut fastball? If so, approximate the pitch speed of the outlier. So Halliday's fastball is Halliday's cut fastball is the third one, and it has an outlier. I want to approximate the speed, and it is in miles per second. So it is around 88 miles per second. So we'll say that 88 miles per second. And we will also say that yes, there is an outlier. Answers this question. There are two more that are based on this graph. Describe the shape of the distribution of Halliday's card ball. So we are talking about the skewness. Halliday's card ball. So you see the left tail is longer. Clearly the left tail is longer in Halliday's card ball. So we go ahead and say that this is left skewed. Describe the shape of the distribution of Halliday's four-seam fastball. So that's the first one. Four-seam fastball. And this one apparently has the right tail longer, I think. So it is a right skewed distribution. So that has answered my question. And we have also ended this section and the chapter 3. So next time we're going to start talking about correlation, regression, and coefficient of determination in chapter 4.